It is a pattern matching, pattern recognition tool. There is no human brain behind it.
Artificial intelligence is a concept so well worn in the annals of science fiction that it's almost harder to think of a sci-fi film or TV show that doesn't include it. From the whopper of war games to Skynet in the Terminator films to HAL 9000 in 2001: A Space Odyssey and the rock computer that lampooned it in Airplane 2, AI has been painted as a dangerously overpowered overreach, just one short circuit from disaster. On the flip side of the script pile, Star Trek The Next Generation's lovable Lieutenant Commander Data is so benevolent that his worst offense is the occasional lame joke, while the soothing if sardonic voice of William Daniels in Knight Rider leaves no doubt that the robot car into which he's built is on the side of the good guys. Yet the reality of AI in our daily lives has become less about grandiose dreams or dystopian nightmares and more about practical applications. It is in the voice-activated assistant that wakes you up in the morning, the algorithm that curates your social media feed, and even the automated system that manages traffic in bustling cities. Despite this less dramatic portrayal, the leaps and bounds made in AI development over the years have been nothing short of remarkable. The vision of sentient machines, once confined to the realms of fantasy, has given way to reality, where AI is not merely a companion or threat, but a ubiquitous tool, enhancing our lives and solving complex problems. This is Living in the Future, a podcast powered by MediaTek that tells the story of technology that's evolved beyond the TV screen, transformed from fantastical cinematic science fiction to actual products that change the way we live and work. I'm your host, Michael Fisher, and this is Episode 4, Artificial Intelligence. Okay, I'm going to fess up here. 5 out of those 6 sci-fi AI examples I just gave you were suggested by ChatGPT when I asked it for podcast ideas. And in fact, the entire last minute of this introduction, so everything after Knight Rider, that was written entirely by ChatGPT. Verbatim, I did not change one word. Yes, I realize it's already an overdone bit at this point, and I'm sorry for the cheap trick. But the truth is, I needed to try out for myself just how good AI could be at, well, being me. And while I'd have made different word choices and hopefully steered a little further from the cliches, be honest, if I hadn't stopped and fessed up here, would you have known that that last minute of me talking wasn't written by me? This is why AI has taken over the tech discourse in 2023, because it's not just good, it's scary good. And it's not just being used to pad out podcast intros, it's being leveraged for all kinds of work that the creative class once confidently predicted would never fall to machines. Folks, just before we get into this interview, I want to say this is one worth listening extra hard to. My guest is a tremendous intellect, and over the course of our conversation, he made me realize just how much natural intelligence it takes to understand artificial intelligence. Actually, that's not true. You just need to listen. And to help you do that, I thought it might be a good idea to review 2 words my guest uses a lot: deterministic and probabilistic. In terms of computer science, a deterministic system is one with no randomness or variation. It will always produce the same output given the same input. Okay, easy enough. Probabilistic, it turns out, is much harder to describe, but the best definition I found was that probabilistic learning is based on the application of statistical codes to data analysis, which, stay with me, which provides a foundation for embracing learning for what it is. Yeah, we're about to talk about learning computers. So, enough preamble, let's dive in. This podcast is sponsored by MediaTek, whose chipsets make intelligent decision-making happen faster. MediaTek powers some of the most popular AI and IoT devices from brands like Amazon and Sony. In fact, over 2 billion products a year, billion with a B, use MediaTek technology. So chances are good you already have a MediaTek-powered device in your life. Dan Mbanga, you're a director in Google's Generative AI Solution Architecture Group. Thank you for taking the time and welcome to the future.
Thanks, Michael. Thanks for having me.
I want to start off with with kind of a broad thing. AI is very hot right now, right? I mean, just everybody's talking about it. And that means it's being used as a buzzword to kind of amplify everything from, predictive keyboards to supply chain solutions. It feels like a lot of tech that's been in existence for years is kind of being rebranded as AI. So my first question is, what's not AI? Or more properly, what makes something just smart instead of artificially intelligent?
Yeah, that's a good place to start. It's true that with a lot of things within the domain of computer science and computing, part of the goal has always been to get the computers to do the things that humans would take a lot of effort and energy to do, right? So that includes automation, that includes adding some calculations or some capabilities that normally would take, originally humans were computers, right? And so the goal with computing has always been to simplify the task and then to accelerate the processes that it would normally take in order to achieve some kind of task or goal. Now, normally you would do that with programming. And as you do approach that with programming, it's super deterministic in the sense that you would have an algorithm, which is a sequence of steps that have a finite amount of effort with a finite amount of time, and then they would get you to the solution and resolution of the task that you're targeting, right?
That's how we used to do it.
That's how we are still doing it in many computer approaches, computer science related approaches to problem solving. Mm-hmm. Now, the challenge with that is that some algorithms are not necessarily, one, they may take forever to complete, or they're not easy to solve in a sequence of steps that is essentially deterministic, right? And when you start having the kind of problems that deviate from the ability to get them to be solved by just writing down a sequence of steps, you land within the domain of what we may call intelligence, or essentially instead of going from almost symbolically and systematically solving a problem by applying a sequence of steps, getting into learning by observations, learning by almost doing, and then learning by observing either an agent or a person or a teacher or anything the way humans would do. That is the boundary between, and from my own definition, that's the boundary between artificial intelligence and normal programming. And so if you want to differentiate between AI and not AI, what I would say is all the programming, problem solving, automation, that doesn't necessarily involve learning. Learning by observation, learning by looking at essentially someone else or another agent, and we can get into the details of that. Those are the not AI approaches. So most of the software that we have now in the life that we are living in, it's not necessarily AI. So web applications, the platform that we're using right now to process the sound, or a lot of computer vision capabilities also are very, very deterministic in the sense that they are using algorithms that are preset, and they're not learning by observing data.
So your browsers, your video conferencing apps, your TV, your smart TV applications, things like that, we would not consider those AI.
Right. And they could be augmented with AI capabilities, which we're going to get into. Mm-hmm. But essentially, if you do know how to solve a problem with a sequence of steps, it's not necessarily AI.
Got it.
It is still intelligence that was encoded in a system, but it's not necessarily artificial intelligence the way we're treating it today.
Because there is not a learning component to it. That's where you draw the line.
Exactly.
personally.
And then when we talk about learning, we are essentially saying, well, it will be too hard for me to solve this problem, or this problem has so much randomness in it that I can't necessarily write a sequence of steps for me to solve it. But there is still a way for me to observe the behavior of that system and be able to mimic it. The same way a child would learn to speak by just observing people speaking. And you don't really know what happens in the child's brain. But after a few days, the child is able to repeat and then catch some patterns and whatnot. So it's a bit of a complex subsystem algorithm, essentially, that we don't necessarily know how to get to, but we know that we can replicate by observation. And then the whole essence of AI is almost to get us in the ability to observe and replicate without necessarily solve from an algorithmic standpoint.
So the learning part I do want to touch on again, because that's one of the more fascinating parts of this. But just to jump ahead slightly, what are some of the places AI is already employed in the real world? Something you would consider AI that might surprise ordinary folks, because I think it is in more places than people expect right now already, right?
That's correct. And it has been in many places for a long time, because AI has evolved over the past, 30 years, right? In the early days, the approach and also the AI approaches have evolved over the past 30 years. In the early days, we tried to solve AI problems by delivering what we call expert systems. Okay. And the expert systems would essentially try to almost have a world knowledge of all sorts of things that would surround human cognition and human abilities, and encode that in some kind of data structure and data store, and essentially put that in the data and computer consumable form, and have some rules on top of that in order to be able to replicate, again, human behavior from a perspective of gathering, almost observing and collecting all types of human aspects and human tasks and task solving aspects, and put that in the computer.
And that's called an expert system, you're saying?
Yeah, that is the expert system approach. And it was observed that it's too hard. Two, we live in an almost infinite system. If you observe a human, it will take you forever to even have an amount of data that can make you believe that you can replicate what that person does.
Yeah, my background is in acting, so I used to do that all the time. It's very hard. Yeah,
exactly. So that approach showed some challenges, but there had been some applications of AI even back then. When you look at, fast forward a bit, in the past 5-10 years, AI has been virtually implemented in almost everything that we do today at different levels of complexity. Some of the early observed and popular applications of AI are things like email spam filtering. When you send an email to someone now, if you remember your mailbox in the early 2000s, you had a lot of spam email, unwanted email coming from all sorts of sources that you don't necessarily care for. But in recent history, it's been possible for your email software to automatically filter some of these emails and then put them in a spam folder. Yes. And if you remember even the evolution of that spam filtering use case, initially it would ask you if an email was a spam or not. And over time, also learning from your answers, these systems have gotten better at determining and picking up which emails are spams, even before you explicitly tell the email software that an email is a spam.
Is that because they can be said to have learned? Is that
exactly? So the whole concept of learning has a time evolution aspect to it, right? So you can train an AI to learn about Michael's preferences around what is a spam and what is not a spam, and over time also observe Michael's answers about what is a spam and what is not a spam, and eventually encapsulate or incorporate that in the behavior of the AI. So the AI components are learning components that can learn over time and improve themselves over time as well when it's done the right way.
There's something I've noticed recently in the past few years with spam filtering specifically. I'm glad you brought that example up, in that it can get worse at things too. It can get better. It can also get worse at detecting spam. And I think that's a very telling example of this difference in error rate between AI solutions and non-AI solutions that I want to get into, because It's funny when these things go wrong, and I think it's fascinating when they do as well.
Yeah, wonderful. And we are definitely going to talk about what it really means to error in that context, because by definition and by nature, these learner systems, learning means that there are going to be moments when you make mistakes, and there are going to be moments where you're accurate, and it's probabilistic up to a certain extent. I know we're going to talk about deep learning and transformers, and in that specific domain, errors are also fairly large. But to get back on other, interesting applications. For example, some of my favorite applications of AI today that are ubiquitous and people are not necessarily aware of are recommender systems, right? So
recommender systems?
Yeah, recommender systems. Almost on every platform you use now, Netflix, Amazon Video, or any other content providing, Spotify, many of these platforms that have a form of consumable asset library. Mm-hmm. That could be movies, songs, and other kinds of things. And then a form of consumers, which are users of different types. There is this mapping, this connection between the users and the products. And if you look at it, you being a user landing on a platform like Spotify and thinking, there is a real estate on the screen of your phone, of your laptop, and then Spotify has to decide how many songs they present to you at that point in time. Mm-hmm. Now, you may say, I have to look at my favorite songs of all times by the factor that I've been listening to these songs forever. That's good. That's a good opportunity. But there might be other songs that are fairly recent in history that you haven't had the opportunity to check yet that you may like. So to understand what to present to you on that limited real estate of your screen, and understand the balance between what you like empirically by the platform knowing that because you have listened to that before, and what you may like as an opportunity, and even understanding the error possibility that may exist there in the sense that we may show you something that you don't like, that you don't want to listen to.
It happens all the time.
So that balance is also a very interesting AI problem that I've worked on recently that involves this concept called reinforcement learning that we can also get to talk about.
That's fascinating you bring that up. It's funny because everyone uses Spotify as the example of that these days, of course. But I remember being bowled over by it in 2008 with Pandora, with that music genome project. And I still, to this day, listen to music that Pandora introduced me to. And I think that even whatever that was 15 years ago, it was doing a better job than some current solutions at predicting what I might like. And even back then, would we consider that an AI solution, like
absolutely,
the Pandora example?
Absolutely. Yeah, absolutely. And that gets us back to your question of what is not AI, and maybe the complementary question is, what is AI, right?
Yes, indeed.
And so if you want to dive into AI, is somewhat of an umbrella term that we've been using in the industry to try to articulate a set of techniques and tools and technologies and even science that we would use to provide some human cognitive level capabilities into computer applications, right? So it's almost that boundary between what I said earlier, this explicit, deterministic, almost sequence-like of solving problems, and the aspect of, I don't necessarily know how to solve these problems, but I'm just going to watch and learn and eventually be able to replicate or model. That's why you hear about models.
Models, yes.
Or model this behavior, right? And so AI really would provide all the tools and technologies and science and techniques to make it so that we can provide or approach these human level capabilities. And in some subdomains, we have actually gone above human level capabilities. And that is related to the amount of data that in recent history we've been able to put into some of these AI systems that we're going to get to talk about.
Yeah, for sure. So is it, just to kind of dip our toe into the philosophical waters a little bit, we'll come back to this, is AI actual intelligence, as we've come to know it from humans and other animals?
What is intelligence?
Yeah, that's a good question.
See, that it's really challenging for me to think about. It's a good way of position the question by saying that it's a philosophical one. And for me, what that means is that you're seeking understanding and knowledge, not necessarily seeking an answer. And I believe that we are all in the same space, right? Where from a neuroscientific and from a human cognition and general philosophical standpoint, we're trying to understand what intelligence is. And at the same time, we have been able to develop these AI systems, and there are many of them. So AI, like I said, is an umbrella term representing many technologies. These AI systems are able to get us closer and closer to at least something that sounds and behaves like us so much that we are impressed. And so for me, the maybe philosophical question is, are we intelligent? Or are we being surprised now that we could be, up to a certain extent, mimicked and or replicated by somewhat simple systems to which we've given a lot of data, to the point where we're getting a lot of things revealed to us about how predictable we actually are, right?
Did you ever surprise yourself with that? Because I do all the time. I'm like, I will pick the same thing on a menu 17 times in a row without even thinking about it. And I'm like, oh, wait, I should probably surprise myself a little more often. Yes, good point.
I believe that there's this underlying, and it's also the working hypothesis of many AI systems. There's this underlying somewhat distribution of probabilistic behavior that we haven't necessarily developed the sensing tooling to be able to probe at a level where we can almost have a lab test of intelligence, if you understand what I mean. So we don't necessarily have the mechanisms and the tooling to be able to probe down to that level, but it doesn't necessarily mean that it doesn't exist if you want to talk about existence in the material form.
It sounds like you're saying there's no way to know right now.
Yeah, I'm saying that we don't necessarily have the tooling that can probe to the depth of, like, the human brain has only been understood up to a certain extent, right? I don't know the percentage at this point, but there is still a lot to learn. And so we do have a lot of behaviors. To your point, you pick the same dish out of the menu and you don't even realize that you're doing that, but there must be a mechanism inside of you that does that, right?
Yes.
So we haven't been able to probe that mechanism yet, but we are able to, at least with certain layers on top of that abstraction, we are able to replicate or model that behavior. So we may be able to have an AI system that observes you order from the menu over a period of a month. And then that system may be able to fool a restaurant by ordering on your behalf just by being able to pick the same dish.
Oh,
so there's
sure.
a difference between touching the real existence in the substrate of the fabric of humanity, mm-hmm. and being able to replicate that behavior at a simpler, higher level to the point where we are impressed with it as if it was intelligence.
Yeah, it's the old adage about sufficiently advanced technology being indistinguishable from magic, right? It's like, is it magic or is it advanced tech? Well, at a certain point, it doesn't matter.
Exactly. Yeah, it does the job.
Yeah. Let's get into the chatbots because we've been dancing around them a little bit. Folks, these are if you don't know, and I was very late to try these out for the first time. I'm relatively new to trying out chatbots, but they're these text boxes you type questions into on the internet and get answers out of, like Bing, Bard, and probably most famously, ChatGPT. A lot of folks probably don't know that many of those current chatbots are built on a common technology called a transformer, which is the T in ChatGPT. In the simplest terms, Danu, if possible, what is a transformer and why is it so powerful compared to earlier forms of machine learning?
Right. I guess I would answer that question in 3 steps, if that's okay.
Sure.
The first step is to differentiate. So we talked about AI as an umbrella term that encompasses all the tools and techniques in science and technology that we have somewhat as a collective put together in order for us to solve some of these advanced computational / intelligence related problems.
Right.
Now, AI itself, if you break it down into the different techniques that have been leveraged in order to solve some of these problems, you hear about machine learning, you hear about deep learning, you hear about data science, and you hear about some of these terms, right? So sure. I would like to clarify that a bit before we get into the transformers, because the transformers stems from that. So within the umbrella of AI, you get the mathematical/statistical techniques that are used, and that's usually within the realm of machine learning.
Okay.
In order to process data and stochastically or statistically and probabilistically analyze, data or behavior in data, so to say. Next to that, and the difference between AI and machine learning up to a certain extent is that within AI systems, you can also have what we call control systems or other robotic kind of applications that are not necessarily within the realm of the mathematics and the statistics of machine learning, but are more in the robotics side of things, right? So
like literal robotics you're talking about?
Yeah, like literal robotics, but nowadays robots are also somewhat virtual, right? So, but when you start thinking about control systems, something that moves an arm, something that does planning, right? Because within the context of AI, you want to sense from an environment, you want to analyze that with some level of intelligence and brain, right? But you also want to plan up to a certain extent this sequence of steps. For example, you can ask a robot that is in a living room to go to the garage and tell you what is the color of the car in the garage, right? And then the robot would have to figure out how to open the door, get out, walk to the corridor, whatnot, open the door of the garage, figure out the color, analyze the color, and come back. So there's a combination of action and analysis that is part of the scope of AI, and that is not necessarily part of the scope of machine learning, because within the scope of machine learning, it's more on the mathematical and statistical techniques of data processing, right?
Okay.
And so then you are in the context of machine learning, which gives you all the tools and techniques that you can use in order to analyze data and process data. And we can talk about what data is philosophically and from a computer standpoint. And then when within the realm of machine learning itself, and that's the evolution, and it's really the change that somewhat changed the game recently, and that's why these things are a lot more popular. So the difference between the spam filtering use case that we talked about, for example, and that GPT use case that we're going to talk about, really resides in three dimensions, and that is the essence of what we call deep learning, and that's also the essence of the transformer. So beyond machine learning, deep learning is an approach for solving the same type of AI problems using the same type of mathematical and statistical techniques. But the difference, or the new thing within the context of deep learning, is that it's based on what we call artificial neural networks. And these artificial neural networks have a structure that mimics the brain structure, the neuron structure of the brain.
So an artificial neural network literally replicates the physical structure of a human brain?
It mimics. You remember, it's a model, right? Because we do not necessarily understand exactly what is the complete structure, chemical, quantum, subatomic level structure of the brain. So that's a much more complex system to literally mimic, but to literally replicate. But we can create a model of it, which is a lot more simplified, and which up to a certain extent, if you simplify enough, gives you similar behavior. So we know that in the brain, neurons fire based on some triggers, and then these neurons activate themselves, and then the signal that gets propagated. And there've been some analysis that were done to understand how different parts of the brain fire for different reasons or whatnot, right? So the whole concept of artificial neural networks and deep learning have been around simulating that behavior into software and use the same machine learning mathematical techniques and approaches in order to get the data as input to these artificial neural networks, and then get these neural networks to fire based on some behavior in the data and or signal, and eventually being able to receive at the end of a traversal or navigation of the entire network, being able to capture a certain higher level behavior. For example, recognizing some objects in an image the way we would recognize some objects by seeing the scene around us.
Familiar elements of that, and essentially designing a system to replicate what happens inside of our brain to cause that result to appear.
Exactly. So that's deep learning. That's artificial neural networks. They give us the ability to do a bunch of things that are similar to the things that we do as humans. Now, the second trend that happened is the fact that big data happened, right? So you go from having systems that make it possible for you to do things that are similar to what humans would do by having a technological advancement in artificial neural networks. The second thing that happens is that the amount of data that gets generated in the last, 6 to 8 years is more than 99% of the amount of data that has been generated forever, just because big data happened, right?
Because we're able to retain all of it now, right?
Yes, and also the internet, the evolution of technologies, apps are being created, websites showed up. So if you remember technology 20 years ago, the only way you could interact with the system was by using a web browser, right? Mm-hmm. But 8 to 10 years ago, it has changed into a proliferation of a plethora of apps that process data. Internet had gotten better. Now people can generate content and then upload that onto systems. So there's just a humongous amount of data that gives the computers the opportunity to learn. So you get this convergence of the almost the science in the artificial neural network. You get the data that gets created in an insane amount in the last few years. And you also get the advancement in computer capabilities, i.e. the speed of the computers.
The processing power, there's just the raw ability.
Right. Raw ability. So your smartphone now is much more powerful than a $1 billion computer 50 years ago.
Absolutely,
right? In terms of, and you've heard of GPUs and TPUs and some of
processing units, tensor processing units, yes.
Exactly. Those are computer chips that make it possible to really, really speed up the processing of that humongous amount of data using these artificial neural network techniques that mimic human behavior up to a certain extent, or that try to model human behavior in the way that they can recognize images, text, audio, and so on and so forth, right? And you get all of these things coming together.
All together, converging. You have these three very different areas converging and accelerating at the same time and resulting in this new ability, right?
Right. And that story is about 7 to 8 years old now, right? In the way, yes, already. So that's pre-Transformers, right?
Wow.
So that all happened, and
this has all been to set the stage for the pouncing onto the scene of what we call a transformer.
Yeah, that's Alexa times, that's, Google smart devices times, that's, if you think about that, Siri times. So these capabilities have existed for a few years, to the point where we've started having intelligent systems that we interact with, right? So natural language understanding, intent understanding, chatbots. We've been using chatbots for a little while now in technology space nowadays, right? Mm-hmm. So there have been some technologies, and there have been some use cases that we've worked on in the last 6-7 years, where with user-generated content on an application, like most of the applications where users could upload an image or video, there are use cases where these applications can parse these images using some AI systems and deep learning systems. Uh-huh. And for compliance reasons, for example, you don't want to see a certain type of content moderation. You don't want to see a certain type of content, and you don't want to have only humans looking at that content over and over. So we've built AI systems in recent history, and I'm talking 7-8 years ago, to parse these large amounts of images that are presented on the internet for different kinds of use cases.
Talking about moderation bots on Twitter, Instagram, things like that.
Things like that, or sentiment analysis, or again, recommender systems and blah, blah, blah. So now what happened in 2017 is that Google wrote and published a paper about a new structure, a new architecture of artificial neural network called transformers. So getting to your question of what is a transformer, a transformer is an evolution of the structure of artificial neural networks that makes it extremely scalable, very easy to process a large amount of data and do some deep learning type of analysis on top of that, right? And the other component of a transformer that makes it revolutionary within the context of these chatbots is what we call the attention mechanism. And the attention mechanism is essentially a feature of the transformers architecture that makes it so that, for example, if you pass a piece of text or paragraph within the transformer for the use case of completing the paragraph, or predicting the next word and the next word and the next word and the next word, which is essentially what these chatbots are doing for within the context of a conversation, then that entire input, the transformer has the ability to essentially compute a score of the relationship of every single piece of that input with each other.
We're kind of in a very specific corner right now. And before we get out of it, I want to ask something that I find probably the most interesting question I think I came up with here. I grew up on like DOS-based Windows machines, okay? And if you type a nonsense word or an invalid command into into an existing type of computer, the type of computer we're all familiar with, it doesn't matter how many times you press enter. It doesn't matter how many times you feed it nonsense. Every time, the result's going to be the same. The computer gives you an error code, or it just sits there and looks at you because it doesn't know what to do with that input. It's the same error code every time. But these transformer-based things that we're talking about, this kind of new generation of AI, is different because it's more vulnerable to some forms of abuse. Like you can enter commands to get them to break out of their ethical and content guardrails that are built into them. You can kind of logic bomb a chatbot like Captain Kirk used to do on Star Trek. That seems to be a uniquely human shortcoming. Why is that possible? Why isn't a chatbot just like any other computer that spits out an error code and says move on?
Yeah, so I think there are about 4 questions in your question.
Probably.
But the first one we somewhat talked about slightly in the beginning when we were differentiating AI from non-AI, right? So if you remember, we said, there is this aspect of solving problems with computer that involves you writing a program. Mm-hmm. And the program does things, and that is deterministic in the sense that you give the same input, you get the same output forever, right? And that is that behavior you just described in the beginning in the older systems where every time you put the same question, you get the same answer, yeah. You would get an error forever, right? Because those were programs, those were applications. There weren't any learner probabilistic behavior thing in the back end that picks an answer based on a probability.
Simple if this, then that. So, yeah.
Right. Mm-hmm. So there's the fundamental difference between solving something with a program and having a piece of AI learner, so to say, as part of an ecosystem of a solution. Right. So that's one of the reasons why you have these differences in behaviors. Now, the second one, the susceptibility to bias and to influences I think there are 2 parts to it. Yeah. One is in the difference or in the non-deterministic in the sense that you can ask the same question to a transformer-based, say, chatbot, and you get different answers. You should try that. You should ask the same question and you realize that you may get different answers. Yeah. And the reason is because these things are probabilistic in nature. And by that it means that the way it predicts the next best word it has to utter to answer you is by sampling from a probability distribution, i.e. it has seen a lot of text, a lot of answers, a lot of discussions, conversations, communication, whatever in the data. And then it has analyzed that during the training of the model. And what really remains after the model is trained is all the calculations of probabilities of the reasons why it may pick up this specific word out of a vocabulary as the next best word. And because it's probabilistic, it means that with a certain probability, it will pick a word and another time it may pick another word. So that is the fundamental nature of these systems. Now, the third thing that you mentioned is the ethical and responsibility and the boundaries. To me, it's a design, it's a human design and almost eagerness problem.
An eagerness problem.
Yes, and I will explain myself. So I work for Google, and we have launched chatbots like Bard. Bard.google.com is one of the chatbots that we've launched. Yes. And like I said earlier, Google wrote the paper about the Transformers architecture in 2017. Right. So we know how to create chatbots and we know how to launch some of these capabilities, but there's a reason why Bard only came out recently. It's because there are heavy guardrails, and there's a lot of work that is going into trying to figure out how responsible these things could be.
Yeah.
And some of these, if you remember in the history of chatbots or automation, there was a chatbot placed on Twitter by a company recently. And then,
Oh, yeah.
and then
It like
and then
immediately became the world's worst person.
exactly.
Yes.
And if you think about how these things work, it's from a technical standpoint, it's not hard to imagine because it learns, right? So it basically ingested all the data and all the things. And again, it's not a person behind it. It just gathers data, analyzes it, and then processes it the way the data is organized,
Yes.
i.e., it will mimic, almost mirror behavior that it observes in the data.
Right.
So it's almost a post-processing exercise to ensure that these outputs or these responses that are provided by the models are responsible given certain guardrails. So from my perspective, it's two angles. One is on the sanity of the input data that you put into the models in order to get them to perform. And the second is on the sanity of the response that you eventually send back to the users. And that's what I call the post-processing. So at Google, we do have guardrails. We do have responsible AI principles. I can recite them to you. It's a list of about 7. It's about socially beneficial. We have to build and test for safety. We have to make sure that we are not reinforcing bias. And what all of that means is that after an answer is provided or when the data set is being considered in order to train the model, we do check them with a huge list of what we call classifiers to make sure that the data is sane and the output is sane. It's an evolving exercise because you cannot always have the answer. And that's why I call it an eagerness problem from an engineering perspective.
I know we are running short on time, so I'm going to cut a lot of my questions, but I have to ask this, and this is going to get outside your area of expertise a little bit, but I have to ask it because it's one thing we're all thinking about. Because AI is threatening its jobs. It's already eliminating jobs, and it has even some podcasters from the future scared about that because, like right before this, I played a game with ChatGPT. I asked it to make up a text adventure for me, like in the world of Star Trek Deep Space Nine. I played it until I ran out of time in the session. And it was pretty good. Like it was writing a novel for me as it went along. I understand why writers are concerned with AI models that replicate voices. I understand why voiceover artists are concerned. But I also understand that anytime there's a new technology, there's a tendency to catastrophize. So what shouldn't people be worried about? What human functions will AI continue to be unable to replicate? What can we rest easy about? I want to give us some kind of balm to that anxiety.
I think creativity is really hard to replicate, right? So things might seem creative to us because it's things we haven't seen before, right? But it's not necessarily creative in the sense of artistic, creativity, right? When as an artist, as you do work, you work within a certain context, you work within a certain domain, and within that domain, you strive to create and be creative. And arguably, there is a lot of work that you do that is not differentiating, right?
Sure. True.
There's a lot of research that you do. If you want to prepare for a session, if you want to write a novel, for example, the character creation, character development, plot creation, plot twist, the maintaining the structure. By that, I mean, for example, if you're working on 5-10 episodes and 4-5-10 seasons, maintaining the same interaction and relationship and structure among some of the characters that you create, so to say, it's a lot of work that humans have been carrying out that are not necessarily differentiating for the aspect of the creative work that they're trying to do. AIs and computers are very good at maintaining that structure on your behalf, like, for example, with the attention mechanism. They're very good at helping you coming up with ideas. Those ideas won't be extremely fantastic. If you ask a GPT model to give you 15 different versions of a certain paragraph that you give it, if it could be a pitch, it could be a plot that you start to develop, it could be an abstract for a piece of work that you're trying to do for your podcast, all of these different things based on some of the existing things that were put in the model before. It could give you versions, it could give you iterations, it could give you different ways you can think about your problem, but it remains an assistant. It remains something that really just helps you within the domain of your expertise move fast. It could help you prototype things incredibly fast. Right? If you want to visualize your ideas and you want the AI to just give you a picture that represents a text that you are thinking about, it could help you with that without necessarily be at the level, and which is part of the work as I described myself initially. What my team does is to really cut through the boundary between the exciting experiment and the actual durable applications within the context of people using that in some commercial domains, right?
Right.
And so if you think about things that way, yes, this thing is exciting now because it's new, it's exciting, and we may get anxious, we may get worried, or we may get excited. But at the end of the day, after the hype settles a little bit, there will be many of things left to do that these AI systems cannot necessarily do. And to me, they're mostly related to the creative aspect of all kinds of work that you do, the things that really need you to come up with some kind of flash within your mind and brain, and really have these deep intuition that you want something to happen. And then the AI systems can really help you either visualize them, automate them, scale them, or prototype them extremely rapidly and take over what I call the undifferentiated heavy lifting. For example, you can create 4 or 5 characters and say, GPT, you know what, give me versions for whatever scene, and then while maintaining the relationships among my characters and this new character over the last 5 seasons or whatnot. And it will give you something that is semantically consistent, but it's still your decision to figure out what would really create the emotions out of the audience that you're trying to target. So I see a synergy, I see a collaboration between the systems as highly automating and creativity enabling assistants. And I see the size of the pie in terms of jobs increasing, actually, which is also something that we're not necessarily factoring in this somewhat anxiety, right? So I see new jobs, new opportunities, and new ways. This is an optimistic outlook, of course, but that's really what I see out of the introduction and then the successful implementation of some of these AI systems.
Well, it sounds somewhat analogous to what must have been the conversations when photography developed. I mean, you formerly had to have immense innate talent or an awful lot of academic learning to make a wonderful painting. And suddenly cameras come out, you can do that in a second. But it doesn't mean that photography isn't an art form. It doesn't mean that there's not a lot of learning inherent to that.
Oh yeah, absolutely. I mean, we have a common friend who's a photographer.
Yes.
And I could take as many pictures as I want. They will never look anywhere near one of the pictures that David would take. Right?
Yeah.
So to your point exactly, we can get the same tools, but we may be able to create different works out of the same tool. And so I see the AI systems as tools, and I see us really as a community of technical folks building the right interfaces that enable the right users to touch these tools and leverage them in a way that helps them. That's at least the reason I signed up for the job.
It's a good reason to sign up for it. My last question was going to be from ChatGPT, but honestly, it was I don't like its question, so I'm not going to do that. I'm going to make my last question one of my own. During your time working on this technology, do you remember a moment that you were really surprised by something, some behavior, some discovery, something that really threw you for a loop?
I would say, for me, it would be this transformer ecosystem. So I've worked on data and analysis, big data, before machine learning became a big thing. I've worked on machine learning before deep learning became a big thing. I worked on deep learning before transformers became a big thing. But even in that evolution, it was almost fairly predictable. The difference from the theory, the mathematical analysis, and the expectation that you may have out of that implementation of a technology, right? So you can almost sequence your thought process, even in planning phase, as to with your expectations of what should come out of a project. And it could be 6 months ahead. So I'm working on this machine learning technique or deep learning technique. I'm going to get data from here. I'm going to process it like this. And this is the kind of things I expect out of the tool, right? But when the transformers came out, and one of the earlier versions of GPT, before OpenAI somewhat made it available to the world in a way that became very popular, I was already working on that. And some of the observations that we had in the lab or in some applications and use cases that we had were just incredible. Some of the early applications were things like write a piece of novel in the style of Shakespeare.
Yeah.
And the kind of text that would come out of it, you would be like, wow, is this thing really coming out of a computer? So that was really my moment of, wow, this thing speaks to almost my soul. But there was the very, very big discontinuity between my expectation of the system and what the system ended up creating. Right. And to me, to me, it was the moment when I started thinking, wow, this thing might have this. We are at an inflection point, so to say, right? So there is going to be a leap. And just to extrapolate on that a little bit, now we're talking about transformers and related architectures within the context of text, i.e. chatbot experiences. Right. But there's this whole concept called multimodal, where you can essentially blend text and images and videos and audios in a way that is almost a plasma of all of these things, right? So like pulling them all together into what we call a common representation. And then so you can have cases, and there's actually literature about that now, where the thing you use to train your model is text and images and videos together. So I'll say that again. So you use text, images, and videos, whatever you want, to train your model. So you kind of blend that into the model.
Yes.
But it remains a chatbot experience, i.e. the way you would interact with a thing remains the text to text, so to say.
Like an instant message thing. Yep.
Like the normal GPT that you're using today.
Typing away.
But the content that we use to create the whole thing has multiple modes, multiple types, images, text, or whatnot. So we're getting into these somewhat multiplexing of input types to output type.
Yeah.
And then you could also go the other way, where you have input type and then multiple output types. And then you can get multi. So this whole thing is about to, in my opinion, become much more interesting. When you, I could see you get that.
Yeah, you just put me. I said I'd ask you my last question, but yeah, there was this thing I was going to bring up, which is people are already talking about, essentially recreating dead people.
Like that's another level.
I know it's a whole thing, but that's what you would need to do, right? You would need to feed it this multimodal set of inputs. You would need to train it on, say, you're reproducing your grandfather, videos and letters that he wrote and emails and audio recordings. And if you could dump all that into the same model, and then if you could go the other way, you could have this virtual representation of your grandfather on a computer screen that could talk in his voice, say things he might say, and suddenly we're in a very strange place.
Yeah, and arguably, it's a picture of you.
No.
It's a video of you. It certainly sounds like you. It certainly may say things you may have said in the past, but there's this information loss as to what are the reasons why you said what you said at that time. What was the processing? What was the computation in your brain and all this? And what is the neurochemical and all these other things in the universe that could have represented. So you can think of a 2D image and video as a projection of you onto a certain surface. Mm-hmm. And there is a decent amount of information lost in that process, right?
Right.
The same way you can, essentially, yes, provided you have some data about what your grandparents have said and whether it's in image or video form, definitely you can train a model that helps you somewhat build that virtual character. But as a collective of technologists and interested parties, I think that we have to remember that these are simplifications and projections, just the same way I could be looking at a picture or video of you. And it's more about that. Now, in a societal sense, yes, it may, just the way we have deepfakes now and whatnot,
yes,
it comes with a certain risk of representation and or misrepresentation
yes,
of different people. So two things about that, and I know it's a longer conversation. One, it's not real people, and two, we definitely have to do a lot of work on how responsible we are about these systems and how able we are to determine the veracity of a certain piece of media artifact as we do observe those. And there are some things that we do in the company I work for to somewhat help at least users verify that the content that we put out there is synthetic, basically AI generated. We add watermarks and we do some other things at Google to make sure that our images and videos and text are marked.
So that something can't be hijacked and held out as a representation of something that was organically generated.
Yeah, it's almost as if we say this is AI generated, folks, just so you know. Right.
Yeah.
And then we're looking for different kinds of interesting mechanisms to make sure that information somewhat is conveyed. But again, this whole concept of eagerness, I think as a collective and on the policy side, we need to figure out other things. Those are larger conversations, but we need to figure out mechanisms and ways to make sure that we don't conflate, we don't confuse these representations, holographic representations almost, with reality, because it's a massive amount of information lost there.
Absolutely.
And it's not the same thing.
Absolutely. Yeah. No, that is going to be really helpful to keep in our head. And maybe we could have a whole nother discussion about this, because they're just understanding it, I think, took more listening power than I have had to leverage in a long time, because I haven't worked out my brain like this in a little while. So thank you, Daniel, for sharing your considerable expertise with us. It's really rare to be able to talk to someone on the inside of making something like this work. And I really appreciate your time today.
Well, thank you, Michael. Thanks a lot for having me.
Listener, if you're sitting there saying, Michael, why didn't you ask this patently obvious question? Or follow up about this totally crucial point? Well, the answer, folks, is that I was just trying my best to keep up. Turns out AI is pretty complicated stuff, as you might expect for a technology that's so good at replicating human interaction. And where we are today, so far down below ground level in the uncanny valley, well, it makes the prospect of an android like Data, or a droid like C-3PO, or an all-knowing, vocally addressable computer like that on the Starship Enterprise, well, it makes all that feel a lot less like fiction already. If you've got thoughts on the future of AI, in fact, or fiction, or you just want to share a particularly interesting text block from a chatbot interaction of your own, please feel free to tweet them to me. I'm at Captain Two Phones. Until next time, thanks one more time to my sponsor, MediaTek, and thanks to you for listening. I've been Michael Fisher, and I'll see you